Today we're going to make Sierpinski triangle in GeoGebra. So we've looked at some animations on the blog of three-dimensional Sierpinski pyramids. Same idea, just another dimension. So the triangle is 2 dimensions, so you start with an equilateral triangle, and you just keep taking iterations or fractals out of it. So you're always doing smaller and smaller and more equilateral triangles, and you're removing area is the idea. So it starts with the solid all red, and then eventually the red is going to decrease. We'll try and find a pattern for that, and the black becomes more and more of the triangle. So we're going to do this in GeoGebra. So if you go to geogebra.org, click the picture, and use this Java web start down at the bottom. It should load up just fine. You don't have to worry about downloading it. Come in here, right click, turn your axes off because we don't need those. Come up to view and go to spreadsheet, and this is going to help us get some good points. So I'm going to do equilateral triangle of length 10, just so the numbers are nice and neat. You can do one of any length that you want. You can do the same, or you can do something different. So if you type in equals here, I'm going to do 1, 1. It'll plot a point for me. I'm going to come down here and go equals 11, 1, and that should be a length 10. Back up to view, turn the spreadsheet off because we don't need that. Come over here, and I'm going to go a segment between 2 points because the line would keep going, and it does spit up as 10, so that's good. Now, if you come over to polygon, and we go to a regular polygon, and you click your side of 10, we want 3 vertices for a triangle, and it spits out our equilateral triangle at us. Now, they were nice enough to compute the area for us up here, which is pretty nice, 43.3. We should be able to do that pretty easy by hand. If we know the base is 10, every angle is 60. So if you look at just one right triangle within there, tangent of 60 is opposite over the adjacent of 5, comes out to 8.6. Area 1/2, the full base, height 43.4. In the calculator, GeoGebra didn't round it quite as much. Okay, so this is going to be stage 1. There's one triangle. Your perimeter should be pretty easy to find, and your area is given for you now. If you want to make your triangle look nice and pretty, we're going to come back up to polygon and go to polygon this time and trace over the 3 points back to the original. Now we should be able to right click on this and go to object properties and go to color, and I'm going to make mine Michigan color. So I'm going to take the blue. You're going to have to drag this opacity up a little bit. So now I have a blue triangle here. Okay? So we are removing area every single time when we do these. So now I'm going to come up to this point, and I'm going to go to midpoint, there, there, and there, and just click those, and it should work for us. So now I'm going to try and do a polygon between those 3 points and back to the original. That polygon's highlighted now, so I'm going to right click on it, object properties, get the maze in here, and bring this up like that. So this piece is now removed. Okay? Now, it was nice enough to do the area for us is 10.83. We still should be able to find that pretty easily. That's what's actually removed. So if you take your original area of the 43 and you subtract the area that you removed, you should be able to find that pretty easily. Now we want to do perimeter here for stage 2. If you pick easy enough numbers, like we did, it should be pretty straightforward. If this whole thing was 10, the midpoint's 5, that means this is 5, 10, 15, and we have 3 triangles of 15. So that should be pretty easy to compute. If you pick some different numbers, or if you just did random points, what you can do is come up here to this angle tool and go to distance or length, and we can click from one point to the next, and it'll spit that out as 5 up here. So then hopefully this should be 5 as well, and it is. So that's one thing that'll help you with those. And you should be able to turn those off or delete those if you don't want them in your final picture. If you don't want those, you can just come up here, right click, and go to delete. Okay, so we were able to get perimeter and area and number of triangles for stage 2. And remember, the triangles, it's not what you remove, but what's left. So in this case, the blue. Now we just want to keep doing this over and over till we find a pattern. And then we want to create a geometric equation to predict what's going to happen for perimeter and area. It's the same process again. We're going to midpoint. Want a midpoint from there to there, from there to there, from there to there. Okay, come back up. I want a polygon, these 3 points. It'll highlight it for me, right click, object properties, I want to make it yellow, bring that up. Now it told me the area of this down here, 2.71. We can also come back up to the angle tool. We should be able to go to area, and if we highlight all of those, it should spit it out at us somewhere. If you're not able to find it over on the side as you get more and more things in here, if you come up to area and you just click the polygon, it'll tell you right there, 2.71, which is the same thing that happened over here. So that's what we're removing. So then you should know the area of this one down here. You should know the area of this one down there, and that can go into your total calculations. Perimeter again. This piece used to be 5, so then this piece has to be 2.5. Think about how many you have for the perimeter of this triangle. How many triangles do you have in this piece, and this piece? So you may have caught on by now, your area is decreasing every time, but your perimeter is increasing every time, which, if you think about it, doesn't make a ton of sense. How can your perimeter get big, but your area get small? And that's what makes this such a unique shape. So that's enough to get you guys going on finishing this up. Make it pretty, go as many stages as you would like. I want geometric equations that model those 3 columns, perimeter, area, and number of triangles. So we could pick any starting area, whether it's 43.3, whether it's 417.9, and predict the area in stage 10, stage 27, stage whatever. Okay, so have some fun with that. After you've done equilateral, I'm going to ask you to do one that's a scalene. So make it not a regular triangle, which you can, or triangle at all. What you can do is just make 3 random points anywhere, like this. Make a polygon between them, and repeat the process over. Okay, have some fun with that, and good luck.